Hey, we've been looking at properties of exponents, and now we're going to throw it all together and see what do we do with that, right? And what I want you to know is that when we use the properties of exponents, there's lots of ways to approach it. Just make sure you're actually using the laws correctly, okay? It doesn't really matter what order you go in for the most part. That power of powers, you got to watch out for that, okay? But for the most part, it doesn't matter what order you do it in as long as you're using them correctly, okay? So don't feel like, hey, there's only one way. And in fact, on your notes today, we're going to look at different ways to approach similar problems, okay? All right, so let's look at A. We're going to do one strategy, and then we'll look, is there another way we could do it? So we have 3 to the x to the negative 2 times y to the 4th divided by 6 times x to the negative 7 times x to the 3rd times y to the 7th. Okay, so I'm looking, and let's just talk for a minute about what you might see here. So I see some quotient rules I could use, right? Because I have x's in numerator and denominator, y in numerator and denominator. I see a product rule right here. I could add those exponents first. So there's a couple different things. We have negative exponents. I could move those if I wanted to, right? So there's a few different approaches you could take. And as long as we end up the same place, we're good. Just use the rules correctly, okay? All right, first let's look at these constants right here because we haven't really done anything with those. Always simplify your constant, right? So 3 divided by 6, we're going to end up with 1/2. Keep it simplified like this in a fraction. Don't do like the 0.5, create some weird decimal within your fraction right now. That's not what we want to do in life, okay? All right, so I don't know. This time I'm going to start with, let's do the product rule right here, okay? So I'm going to leave x to the negative 2. And I'm going to look at my x's in the denominator right here. Remember my quotient rule, my product rule says when I multiply same bases, I add the exponents, right? So I have x to the negative 7 plus 3 would be x to the negative 4th. Okay, so I'm going to write that x to the negative 4th right there. And now I see there's y in the numerator, y in the denominator. I'm going to go ahead and let's use the quotient rule here. Okay, quotient rule says when I divide the same bases, subtract the exponents. So I would have y to the 4th minus 7, which is going to be y to the negative 3. So I'm going to have y to the negative 3 right here. Okay. All right, we're not done yet because we want to end up with everything positive. That's where we're moving right now. Okay, so I can see I have all these negative exponents. Like, let's get rid of those, right? So let's look at our x's. Now I have the quotient rule with my x's. Okay, so x to the negative 2 minus negative 4. So that's the same as saying x to the negative 2 plus 4, which is actually x squared. Okay, I have a higher exponent in the numerator. Negative 2 is greater than negative 4, so this x squared should end up in the numerator. And then I have y to the negative 3. There's no other y's, so that this one has to cross the line and change the sign. Okay, so that is one way that I could approach this problem. So I did my product, quotient, then I did quotient and simplified. Let's look at another way, okay? I always still want to start with those constants. Let's just always simplify that right away. So I know I'm at 1/2. And then I'm going to deal with, let's say, these negatives, right? So I know the top one has to come down and this bottom one has to move up, okay? So let's go ahead and do that. So x to the positive 7, and then I have x squared times x cubed, right? And then the y's, it's still going to be that quotient rule. So I'm just going to go ahead But this time I'm going to look at it, I have, where do I have the higher exponent in my denominator? How many more is 7 than 4? It's 3. So I can just go straight, it stays in my denominator, that's where I'm going to have more of them, and I drop it down there, right? I could, if I'm not sure about these rules, remember you could expand it. 5, 6, 7, right? That's 1, that reduces to 1, that reduces to 1, that reduces to 1. I'm left with 1, 2, 3 in my denominator. Sweet, right? Okay, so let's keep going. I still have these x's here that need to be simplified. So 1 over 2. If I look at my x's, okay, I could do all of this at once, but if that confuses you, just do one at a time, right? So this could be x to the 7 minus 2, which is x to the 5th. So I would have x to the 5th, and then I still have that x cubed, and then I have y cubed, right? Okay, but I'm not done. Remember, we want all the variables simplified all the way. So if I do the quotient rule one more time, x to the 5th minus 3 gives me x squared. That's in the numerator because I have more up here than down here. And then my y cubed stays in the bottom. We ended up the same. Woohoo! That's just two different ways to approach the same problem. There's other ways you could do it too. If you find a different way, awesome, but we should all get to the same destination. All right, so let's look again. Example B. All right, so we have all of this to the power of 3 divided by this. Okay, so I'm going to just tell you right now, we're going to want to take care of this power of a power first. Okay, that one has to be what we're going to do. Remember, power of a power multiplies the exponents. Okay, remember, constants have an exponent as well. If you don't see it, it's still 1, just like with our variables. All right, so we're going to do this, and we have 2 to the 3rd, because it's 1 times 3. I have b squared times 3, c to the negative 1 times 3, all over 4b to the 8th, c squared. Right, let's simplify this. So that's 2 to the 3rd. 2 to the 3rd is 2 times 2 times 2, which is going to be 8. So I'm going to have 8 fourths, and now I'm going to switch colors on you. Okay, so we're going to have b, and this is 2 times 3 is 6. And we have b to the 8th in the denominator. And then we have our c's. C to the negative 1 times 3 is negative 3. And then we have c squared. Okay, let's simplify the constants. 8 divided by 4 is 2. Okay, now we're going to look here. I can simplify this. I could simplify that negative first, right? A few different ways to do this. So if I have this, I have b to the 6 minus 8, which is b to the negative 2. So I can do b to the negative 2. And then our c's, okay, quotient, same base divided, subtract. So negative 3 minus 2 is c to the negative 5. Okay, so I'm at c to the negative 5. All right, and then we have these negatives. Notice everything bumped up to the denominator when I did that. Here we go. This moves and this moves. So we end up with 2. Oh, I don't like that that's right there. Let's write it over here because I think you're going to think that's a fraction. All right, so we have 2 stays, but now that b to the negative is going to cross the line. An exponent changes its sign, and our c is going to cross the line and change the sign. Okay, all right, so a little bit confusing. Let's try a slightly different way. Here we go. I still have to start with that power, right? So 2 to the 1 times 3 is 3. B to the 2 times 3 is 6. And c to the negative 1 times 3 is negative 3. Okay, all over, and then I have 4 and b to the 8th and c squared, right? Okay, so constants first. 2 cubed was 8 over 4. All right, I can look at my b's. Where do I have the higher exponent? I have 8 in the denominator, so b is going to end up in the denominator. How many more? There's 2 more, so that would leave me with 2. All the other ones would reduce to 1, right? Okay, what about our c's? Where's the higher exponent? 2 is higher. How much higher? Well, I'm at -3. I want to get up to +2. How much do you have to move? Well, just to get to 0, I have to move 3, and then I have to move 2 more to get to 2. So I'm at 5, so this has to be c to the 5th. And now reduce our constants. So 8 divided by 2 is 4, and we end up with 2 over b squared times c to the 5th. Okay, different ways of thinking about it gets us the same place. One more example, here we go. All right, we have 2 to the x, 2 times x to the third, y to the -3, all to the -1. So there's a few things that we could do. We have these negatives, we have this negative, right? So let's see what happens here. I'm going to take this negative first, and I'm going to move it down, right? So then what happens is I have 2x cubed over y cubed, right? Cross the line, change the sign, all to the -1, okay? And so that -1 tells me to flip, right? Cross the line, change the sign. So essentially that's telling me to swap everything in the position. Okay, remember this is just a big blown up scary story. But remember, if this was just n to the -1, we would cross the line and change the sign. Okay, so we're going to cross the line. We're just going to flip everything. So y cubed over 2 times x to the third, right? And that would be it, because then we cross the sign and we change the sign, so now it's positive. That's what we should end up with. Was that confusing? Let's look at another way, okay? All right, if we have power of a power, remember that tells me I multiply this power times all of the exponents. Remember 2 is raised to the power of 1, okay? Always remember everything has an exponent even if you don't see it, okay? So if we multiply that out, we have 2 times 1, 2 to the 1 times -1 times x to the 3 times -1 times y to the -3 times -1. All right, we have 2 to the -1, because 1 times -1 is -1, x to the -3, and y to the +3. Okay, well, negatives, cross the line and change the sign. So I have 2 is going to move, and my x is going to move. Y is going to stay put, so I have y cubed stays, and then I have 2, and now it's to the +1, and now I have x, and now it's +3. I kind of like this way better. But you know, it's how does your brain process it? Okay, so think about that, different strategies. You can do it. Let's put it all together.